2 a.m. PagerDuty fires. Your Kubernetes cluster is down. Not because of a bad deployment, not because of a network partition, but because an LLM inference job just requested 100 GPUs, and your node autoscaler has absolutely no idea what a GPU pool is. The on-call DevOps engineer, 7 years of experience, AWS certified, Terraform expert, is staring at a kubectl-described node output they have never seen before. Pending pods. Unschedulable. Resource NVIDIA.com GPU unknown. I watched this exact scenario play out at a Series B AI startup in late 2023. The team had world-class DevOps skills. They knew Helm, Argo CD, Prometheus, the full stack. But nobody on that team had ever touched NVIDIA device plugins, dynamic matching queues, or GPU memory fragmentation. These were problems that simply did not exist in their world 18 months earlier. And here is the brutal truth. The incident lasted 6 hours. Not because the team was incompetent, they were excellent, but because their entire mental model of infrastructure was built for CPU workloads, stateless services, and horizontal pod autoscaling. The AI workload broke every assumption they had. The tools they knew were the wrong tools for the job. By the end of this lecture, you will know exactly which assumptions are expiring and what to replace them with. Now, you might think that was an edge case, a one-off incident at an AI-first company. Let me show you why it is not. Gartner published a prediction that platform engineering will reach mainstream adoption by 2026. And if you look at hiring data right now, that transition is already faster than anyone expected. I pulled job posting data from LinkedIn and Greenhouse in Q1 2024 at companies like Meta, Google, Stripe, and Databricks. What used to be called DevOps engineer in the job title is now platform engineer or developer productivity engineer. The ratio has flipped. Platform engineer postings outnumber DevOps engineer postings by roughly 3-to-1 at FAANG tier and AI-first companies. And here is the part that should genuinely concern you. The salary band for platform engineers at these companies is 20 to 40% higher than equivalent DevOps roles. This is not a rebranding exercise. The job description is fundamentally different. They are not asking for someone who can write a Jenkins file or manage an EC2 autoscaling group. They are asking for someone who can design an internal developer platform, an IDP, that lets 200 engineers self-serve their entire infrastructure lifecycle without ever filing a ticket. That is a completely different discipline, and most DevOps engineers are not trained for it. But here is the question you need to sit with. What exactly is the gap, and can it be closed in time? Okay, so the platform is burning. The question is, what do you actually do about it? Let me be very specific about this lecture will give you, because I hate courses that promise transformation and deliver slide decks. First, you will be able to run a structured audit of your current DevOps skill set against a platform engineering competency framework. Not vague categories, specific tools, specific capabilities. Can you design a backstage software catalog? Can you build a golden path template that abstracts Terraform, Helm, and CI/CD into a single developer interface? Do you understand the difference between a paved road and a guardrail, and when to use each? Second, you will be able to identify your exact capability gaps, the 3 specific areas where most DevOps engineers fall short when trying to transition. I've interviewed over 40 platform engineering candidates in the last 2 years. The same 3 gaps appear every single time. Third, you will leave with a concrete 90-day learning plan. Name tools, name deliverables, week-by-week checkpoints. Not learn Kubernetes, but deploy a backstage instance with a custom scaffolder template by day 30, wire it to a real cross-plane composite resource by day 60, and demonstrate a developer self-serving a full cloud environment in under 5 minutes by day 90. That is the bar. And it is achievable. But wait, there is one item on this checklist that almost every DevOps engineer skips, and it is the one that gets them rejected at final round interviews. Here is the full map of where we are going in this lecture, and why each stop matters. We start with the evolution timeline, DevOps to SRE to platform engineering. This is not just history. Understanding the progression tells you precisely which skills from your current toolkit transfer directly, which ones you need to extend, and which ones are simply becoming obsolete. We go deep on the 3 capability gaps. These are not soft skills, they are hard, technical gaps. Product thinking for infrastructure. IDP architecture with backstage and port. And the one everyone misses, making your platform observable to the business, not just to engineers. Then we hit the layer that separates 2024 from 2026, AI integration inside the IDP itself. Not AI as a workload you support, AI as a component of the platform. Think AI-assisted scaffolding, intelligent golden path recommendation engines, LLM-powered runbook automation that fires before a human even pages. This is where the real gap opens between engineers who adapt and engineers who get displaced. Building this right now, Vercel, Linear, PlanetScale, they are not hiring DevOps engineers to run these systems. They are hiring platform engineers who can build the infrastructure that thinks. Next chapter, we start at the beginning of this evolution timeline, and I promise you will see patterns you recognize from your own career in a completely new light. Let's start with the DevOps era, 2010 to 2018. The origin story. Tear down the wall between Dev and Ops, automate everything, ship faster. And for a while it worked. But here is what actually happened on the ground. Every team wrote their own Jenkins file. Every squad had a different Docker base image. One team was on Ansible, the next was on Chef. The one down the hall had never heard of either and was still SSHing into boxes manually. We called it DevOps culture, but what we actually built was a new kind of silo. Not Dev versus Ops anymore, but Team A versus Team B versus Team C. I personally spent months at a fintech trying to consolidate 17 different CI pipeline implementations across 12 squads. 17. Same company, same product, 17 different ways to build a container. The wall of confusion did not go away, it just got distributed, and that is the brutal irony of the DevOps era. So what did the industry try next? That answer changed everything. Google's answer was SRE, Site Reliability Engineering. And this is where things got genuinely sophisticated. The core insight was brilliant. Treat operations as a software problem. Introduce error budgets so that reliability becomes a negotiation, not a religion. Define SLOs, service level objectives, with actual math behind them. Measure SLAs, the indicators, against SLAs, the agreements. Eliminate toil, which Google defined as manual, repetitive operational work that scales linearly with traffic. I have to be honest, when I first read the SRE book in 2017, I thought it was the end state. This is it. We solved ops. But here is the catch that took me 2 years to see in production. SRE is fundamentally dependent on individual engineers holding tribal knowledge. Your error budget policy is only as good as the one senior SRE who wrote it and remembers why. When that person leaves, and they always leave, you are back to guessing. SRE gave us the right metrics and the right philosophy, but it did not solve the knowledge distribution problem. And that gap, that is exactly what platform engineering was built to fill. So here is where platform engineering enters. And this is the synthesis moment that most people miss when they first hear the term. Platform engineering is not just DevOps with a fancier name. The fundamental shift is this. Instead of every development team solving the same infrastructure problems independently, a dedicated platform team builds a product, an internal developer platform, or IDP, and that product is what application developers consume. Think of it like this. You are not giving developers a shovel and telling them to dig their own well. You are building the waterworks, and you are exposing a tap. Developers turn the tap. They do not need to know how the pipes work. We call this the paved road, the golden path that works out of the box, with guardrails, with observability pre-wired, with security policies already baked in. The cognitive load reduction is the entire point. A developer should be able to deploy a new service to production without filing a single ops ticket. Not because ops does not exist, but because ops baked all their expertise into the platform itself. This is a fundamentally different mental model. And it is why the job description changed more in the last 3 years than in the previous decade. Let me show you something that I find more revealing than any industry report. Pull up a 2020 DevOps engineer job description next to a 2025 platform engineer. I have done this exercise with my own LinkedIn saved jobs folder. The surface looks similar: Kubernetes, Terraform, CI/CD, monitoring. But look at the verbs. In 2020, maintain pipelines, manage infrastructure, respond to incidents. In 2025, design internal APIs, define developer experience metrics, build self-service workflows, treat the platform as a product with a roadmap. That word product is doing enormous work here. A platform engineer needs to think like a product manager for an audience of internal developers. My users. What is their friction? What is their MTR when they hit a wall? What is my platform's API contract, and how do I version it without breaking 12 consumer teams? I have interviewed over 40 engineers in the last 2 years for platform roles. The ones who struggled were technically excellent but had never thought about developer UX as a discipline. They could write great Terraform. They could not write a great README. And in platform engineering, the gap costs you. Now here is where it gets concrete and uncomfortable for a lot of engineers. Your performance review now depends on metrics you cannot control alone. DORA metrics, deployment frequency, lead time for changes, change failure rate, mean time to restore. These were always organizational measures. But in platform engineering, they become your platform's product KPIs. Think about what that means. If deployment frequency is low, it is your platform. Maybe the self-service deploy workflow has too much friction. If change failure rate spikes, your platform's automated testing gates failed to catch it. You are accountable for outcomes you enable, not just systems you operate. I have seen this break engineers who were fantastic at the technical work, but had never owned a metric they shared with the CTO. Here is the table I actually use when building platform OKRs. Deployment frequency maps to platform API call volume. How often are teams using your deploy primitives? Lead time maps to P95 time from Git push to production. Change failure rate maps directly. If your platform baked in bad defaults, you own that number. MTTR maps to how fast your platform's stack surfaces the blast radius. These are not vanity metrics. They are the platform's SLO, and failing them has career consequences. Next, we look at what completely rewrote this equation in 2024. Here is the thing nobody was talking about in 2022 that is now the reason every company is accelerating toward platform engineering. AI workloads completely break the traditional DEL model and structurally break it. Let me give you the concrete picture. You get a request to deploy a new LLM-based feature. In old-world DevOps thinking, you Dockerize the model, write a Kubernetes deployment YAML, hook it into your existing CI pipeline. Done. Except the model is 40 gigabytes. It needs A100 GPU nodes that have to be provisioned, warmed, and kept warm because cold start latency on a GPU cluster is measured in minutes, not milliseconds. You need inference autoscaling that responds to token throughput, not just HTTP request count. You need cost per token monitoring because the CFO is asking why the cloud bill tripled. You need model version pinning so that the same experiment does not randomly switch model weights on Tuesday afternoon. None of this fits into a Jenkins file. None of this fits into your existing Helm chart templates. I have watched 3 different teams try to bolt GPU management onto their existing DevOps toolchain. Every single one ended up building a bespoke platform layer anyway, just without the design discipline. AI workloads are not a new use case for DevOps. They are the forcing function that proves you need a real platform. Now let me clear up a confusion that I see constantly, even in senior engineering discussions. MLOps and platform engineering for AI are not the same thing. They operate at different layers and they serve different users. MLOps is about the data science workflow, experiment tracking, feature stores, model training pipelines, evaluation frameworks, the feedback loop from production back to training. MLOps serves data scientists and ML engineers. Platform engineering for AI, which is increasingly just called AI platform engineering, is the infrastructure product that MLOps teams sit on top of. It answers, how do I give a data scientist a GPU environment on demand without them filing a ticket? How do I expose a model registry API that the feature team can call from their own deployment pipeline? How do I make vector database provisioning self-service so that the RAG application team does not need to know that Weave8 even exists as a Kubernetes operator? This is the layer most DevOps engineers are being asked to build right now in 2025 and into 2026. And the vast majority do not realize they are building a platform product, not a pipeline. The ones who do realize it, who bring product thinking, API design discipline, and developer experience metrics, those are the engineers who will own this decade. And in the next chapter, I will show you exactly what that platform architecture looks like when it is done right. Let me be brutally honest with you. Most teams building an internal developer platform start with the wrong thing. They spend 6 months customizing Backstage, making it look pretty, adding plugins, tweaking the UI, and then wonder why developers still open Slack and ask ops for help. Here's the truth. A beautiful portal without the right pillars underneath is just a fancy ticket system with a nicer font. A production-grade IDP has exactly 5 pillars. First, the service catalog. This is your Backstage core, the single source of truth for every service, owner, dependency, and runbook. Second, golden path templates, opinionated, pre-approved scaffolding that gives developers a paved road instead of a jungle. Third, self-service provisioning. This is the one that actually eliminates tickets. Fourth, observability integration, metrics logs, traced in from day 0, not bolted on later. Fifth, secrets management, vault or external secrets operator, non-negotiable. Now here's the pattern I've seen in over a dozen platform teams. They always build secrets management last. Always. And it's exactly backwards, because without it, developers start hard-coding credentials in environment variables, and you inherit a security disaster. Build secrets management first, portal second. But even when you get the order right, there's a second trap waiting for you, and it lives inside the tech stack itself. All right, let's talk about the actual tech stack you'll be assembling in 2026. Because the ecosystem has shifted significantly, and picking the wrong tool at the wrong layer will cost you months of refactoring. Think of the IDP stack as 4 distinct layers stacked on top of each other. At the top, the portal layer, this is Backstage, full stop. Yes, there are alternatives like Port or Cortex, But Backstage wins on extensibility, and the plugin ecosystem is now mature enough that you're not writing everything from scratch. The second layer is infrastructure abstraction. This is where diverge. You have two real choices. Crossplane, which models infrastructure as Kubernetes custom resources and lets you compose cloud resources the same way you compose application manifests, or Terraform CDK, which stays in familiar Terraform territory, but brings programmatic composition. My honest take after running both in production? Crossplane wins if your team lives in Kubernetes. Terraform CDK wins if your team has deep Terraform expertise and doesn't want to retrain. I've seen teams try and the state management becomes a nightmare. Third layer is GitOps delivery, Argo CD, specifically with application sets for multi-tenant platform management. And at the bottom, the enforcement layer, this is your Kubernetes operators. OPA gatekeeper for policy, KEDA for scaling, external secrets operator for secrets sync. The operators are what make the platform self-healing. But here's the real question. What does a developer actually experience when all these layers are working together? That's the next scene. Now let me walk you through what the developer experience actually looks like on a mature IDP. Because this is the part that makes every ops engineer either deeply satisfied or slightly nervous about job security. A developer on your platform opens Backstage, clicks Create Service, picks the Node.js microservice a golden path template, fills in 4 fields: service name, team owner, environment tier, and database required yes or no. They hit submit. What happens in the next 90 seconds is the entire value proposition of platform engineering. The template triggers a Backstage scaffolder action that creates a Git repository with pre-configured GitHub Actions workflows. Crossplane provisions a Kubernetes namespace with resource quotas already set. If they check database required, an RDS instance or Cloud SQL is provisioned via a crossplane composition, and the connection string is automatically stored in Vault. Argo CD detects the new repo and creates an application pointing at it. Grafana dashboards are auto-provisioned using the Grafana library. The developer gets a notification. Your service is live and staging. Push to main to deploy. No ops ticket. No waiting. No Jira comment saying working on it. I've watched senior developers when they see this for the first time. Not because they're impressed, because they're doing the math on how many hours per week this replaces. But here's the catch that every tutorial skips. The golden path only works if you actually enforce it. And enforcement is where things get ugly in production. That's what the next chapter is about. Let me describe a real incident I dealt with 2 years ago before we had AI integrated into our platform. 3 a.m., alert fires, P1 in production. My on-call engineer spends 40 minutes just trying to correlate. Was this a deployment, a traffic spike, an upstream dependency? He's tabbing between Datadog, GitHub, Confluence, and Slack history simultaneously, copy-pasting log snippets, trying to form a hypothesis. That 40 minutes of correlation time. Here's how AI incident response works directly into the IDP in 2026. When PagerDuty fires a P1, an LLM agent, we're using a fine-tuned GP4 class model with tool use, immediately queries 3 sources in parallel. First, it pulls 5 deployments from Argo CD and diffs the manifests. Second, it searches the vector-embedded runbook database for similar past incidents using semantic search. Third, it queries Datadog metrics for anomaly patterns in the 30 minutes before the alert. Within 60 seconds, the agent posts to the incident Slack channel a natural language summary of the likely cause, the specific rollback command if a deployment is implicated, a draft incident report pre-filled with timeline and impact, and a confidence score. Your on-call engineer is no longer a detective, they're a decision-maker reviewing an AI hypothesis. MTTR drops from hours to minutes. Now, I want to be honest here. The LLM is wrong about 15% of the time in my experience. That's why the platform engineer's job is now building the feedback loop. Every time the AI hypothesis is wrong, that becomes training data. The engineer who understands how to build that loop is worth 3 engineers who just respond to alerts. Let's talk about autoscaling, because this is an area where the gap between traditional practice and AI-assisted practice is enormous and immediately measurable. Traditional HPA, horizontal pod autoscaler, is rule-based. You set CPU threshold at 70%, you summary threshold, you set min and max replicas. Simple, predictable, and completely blind to context. It doesn't know that every Tuesday at 2 p.m. your batch job runs. It doesn't know that a marketing email going out will spike traffic in 20 minutes. It reacts, it doesn't anticipate. KEDA with AI-generated scaling policies changes this. Here's the comparison that matters. With traditional HPA, your platform team writes scaling rules based on gut feel and past incidents. The rules are static YAML that someone has to remember to update when traffic patterns change. With ML-based predictive scaling, an ML model, trained on your historical Prometheus metrics, deployment events, and external signals like business calendar, generates the key to scaled object manifest automatically. It writes the cron-based triggers, the custom metric thresholds, the cooldown periods. Platform engineers' job shifts from writing YAML to validating AI output and maintaining the model's training pipeline. Now here's the uncomfortable question this raises. If the platform is writing its own scaling policies, what happens when the AI gets it wrong and you've scaled down during a traffic? I've seen this exact failure. And the answer is not to distrust AI-generated policies. It's to build the right validation gates. The deployment risk scoring system in the next scene is exactly how you catch this. The last piece of the AI integration layer is one I'm genuinely excited about because it directly addresses the #1 cause of production incidents in every company I've worked at: confident deployments that should never have been made. Deployment risk scoring. Here's how it works in a mature IDP golden path. When a developer opens a pull request, an LM agent receives the diff, not just the code, but the full context. Which services are affected? What's the deployment frequency of this service? What's the historical incident rate for changes to this file path? The LLM then does 3 things. First, analyzes the semantic content of the diff. Is this touching authentication logic, database migrations, rate limiting? Your high blast radius change categories. Second, it queries your incident database using vector search to similar past changes and what happened. If 3 previous changes to the auth middleware caused outages, that's a strong signal. It assigns a blast radius score from 1 to 10 and recommends a canary percentage. Score under 3, standard deployment, 20% canary for 10 minutes. Score over 7, mandatory phased rollout, 1% canary, require on-call acknowledgement before proceeding. This is baked into the IDP golden path, meaning it's not optional. You can't bypass it by pushing directly to main, because the Argo CD application is configured to require the risk gate to pass. Now, the reason this matters beyond just safety: it starts to create institutional memory that survives engineer turnover. Every deployment decision, scored and logged. That historical dataset becomes more valuable every month. What you build in 2026 is not just a platform. It's a learning system. And that learning system is what will define platform engineering for the next decade. All right, let's talk about the part of platform engineering that most DevOps engineers are completely unprepared for in 2026: GPU infrastructure. 2 years ago, GPU clusters were the AI team's problem. Today, if you're building an IDP and don't have a GPU story, your data scientists are spinning up unmanaged EC2 instances with CUDA installed, and your FinOps team is having a heart attack. Here's the Kubernetes reality. You need 3 things working before you can abstract GPUs for end users. First, the NVIDIA device plugin as a daemon set. This advertises GPU capacity to the Kubernetes scheduler. Without it, pods can't request GPUs. Second, and this is where most teams get tripped up, MIG, multi-instance GPU partitioning. An A100 GPU can be partitioned into 7 MIG instances, 1 and 10 gigabit slices. So you're not forcing a data scientist to reserve an entire A100 for a Jupyter notebook experiment. The Kubernetes configuration requires the NVIDIA.com MIG strategy annotation on the node, and your GPU node pool needs MIG mode enabled in the NVIDIA operator config. Third, time slicing for dev and test workloads. This is software-level sharing, not hardware partitioning, acceptable for inference development but never for training. Now here's what the IDP abstraction looks like for the data scientist. They fill in a form in Backstage. They select GPU tier, small, and the platform translates that to a MIG 10 gigabits slice request. They select GPU tier training, and they get a full A100 with a spot instance fallback policy. They never see a node selector. They never know what MIG is. That abstraction is the entire value. But abstraction without cost visibility is how you burn $50,000 in a weekend. That's the next scene. Let me tell you how you burn $50,000 in a weekend on GPU infrastructure without even realizing it. I've seen it happen. A data scientist kicks off a training job on a full 100 on-demand instance on Friday afternoon. The job crashes silently due to an OM error. The pod restarts, because the restart policy is set to always, which someone copied from a web service config. It restarts 8 times over the weekend, each restart. Another hour of A100 on-demand time. Nobody is paged because the team doesn't have GPU utilization alerts. Monday morning, a very uncomfortable conversation with the VP of engineering. The FinOps layer for GPU clusters is non-negotiable, and it has 4 components that your IDP must surface. First, cost per model request visibility. You need to instrument your inference services so you know exactly what it costs in GPU seconds to serve prediction. This requires custom Prometheus metrics and a Grafana dashboard that finance can actually read. Second, spot instance fallback for training workloads. Training jobs are interruption tolerant if you checkpoint properly. Your IDP template should enforce checkpointing every 15 minutes via a sidecar and use Spot with on-demand fallback as the default for training node pools. Savings, 60 to 70% on training costs. Third, reserved capacity for inference. Your production endpoints cannot run on Spot. Reserved GPU instances for inference workloads, Spot for training. This distinction must be enforced by the IDP, not left to the data scientist. Fourth, a GPU utilization dashboard that shows real-time utilization per team, per model, and per environment, and critically, alerts when a GPU node under 30% utilization for more than 20 minutes. Because idle GPU is the most expensive kind of infrastructure waste you can have, platform engineering for AI workloads is not just DevOps with a GPU attached. It's a completely different discipline, and the teams that master it in 26 will be untouchable. But all of this beautiful architecture, it breaks in production in ways no tutorial will ever warn you about. That's exactly what we're diving into next. Let me tell you about the most painful 6 months I've ever watched a platform team go through. They built a gorgeous internal platform, beautiful UI, backstage-powered catalog, one-click deployments, the works. Launch day comes, Slack announcement goes out, and then, crickets. 2 weeks later, I'm sitting in their retrospective, and I see the telemetry data. 7% adoption. 83% of developers are still running their old bash scripts from 2021. Why? Because the golden path added exactly extra steps to what they already knew how to do. And worse, there was no escape hatch. If your use case didn't fit the template, you were completely stuck. So what did developers do? They went around it entirely. Classic shadow IT, but internal. The platform team had spent 6 months optimizing for their own mental model of how deployments should work, not how developers actually work. That gap between what looks right on a whiteboard and what gets used at 2 a.m. during an incident is exactly what this chapter is about. And trust me, the AI automation story coming up next is even more painful. Here's the mindset shift that changes everything. Your IDP is not infrastructure. Your IDP is a product. And your developers are your customers. This sounds obvious until you realize that almost no platform team runs user research sprints, measures developer NPS, or as a product manager. They have engineers who are really good at Kubernetes and Terraform, but have never interviewed a user in their life. The paved road principle, coined by Netflix, says the platform should make the right thing easy and the wrong thing hard, never make the right thing impossible. And critically, you need to measure whether developers are actually happy using it. Run quarterly NPS surveys. Track inner loop metrics. How long does it take from push to running and staging? That's your North Star. If your IDP makes the inner loop slower, you have failed, regardless of how clean your GitOps pipeline looks. Platform teams that treat developer experience as a first-class metric consistently hit adoption rates above 70%. The ones that don't, you already saw the number. But measuring is just the beginning. Let me show you the specific pattern that fixes this. All right, so what's the concrete fix? It's called the escape hatch pattern, and it's non-negotiable. Every single golden path you build must have a documented override mechanism, a way for a developer to say, I know what I'm doing. Let me go off-road, just log that I did it. In practice, it looks like a flag in your platform CLI, something like ip deploy, override template custom, which bypasses the template validation, but writes an audit entry. The second rule is dogfooding. The platform team must use their own IDP to deploy their own services. Not a demo service. Their production services. Because the moment you feel the pain of your own golden path, you find the gaps instantly. I've seen teams that dogfooded their IDP find and fix 11 critical UX issues in the first 2 weeks that their users had silently suffered for months. And third, opt in before opt-in only. Roll out the new golden path alongside the old way, let developers migrate at their own pace, and only deprecate the old way once adoption is above 80%. Progressive adoption beats forced migration every single time. Coming up next, what happens when you do get adoption, but your AI automation decides to help in completely the wrong way? This one still makes me angry when I think about it. A fintech team integrated an AI-powered auto-remediation system into their IDP, one of the shiny new AIOps tools that promises to detect anomalies and automatically fix them. 3 weeks after launch at 2:47 p.m. on a Tuesday, their AI system detects what it classifies as a failed deployment. Confidence score, 24%. It auto-triggers a rollback. Deployment goes back one version. Services start restarting. And then the real outage begins, because the deployment was actually fine. The alert was a false positive from a Prometheus alerting rule that someone had misconfigured to fire on cold start latency spikes, which happen every single time a new pod initializes. The AI had never seen that pattern in its training window. It saw high latency, saw a recent deployment, connected the dots incorrectly, and confidently destroyed a working system. 40 minutes of outage. Not from the original deployment, from the rollback. The post-mortem conclusion was brutal. We gave an LLM agent direct cubicle rollout, undue access in production with no human gate. That sentence should be burned into every platform engineer's brain. But here's the question: how do you still get the speed benefits of AI automation without this risk? So what's the right architecture? You keep the AI in the loop, but you gate every consequential action be things, a confidence threshold, and a blast radius score. Here's how it works in practice. Your AI agent analyzes the incident signal and proposes an action. Before that action executes, the system calculates blast radius. How many services does this affect? How many users? Is this a stateful operation? If blast radius exceeds a defined threshold, say level 3 out of 5, the action goes into a human approval queue. The on-call engineer gets a Slack message. AI recommends rollback of service X, reasoning, latency 99 exceeded SLO for 8 minutes post-deploy. Blast radius, 4 or 5. Approve or reject. Engineer reviews, approves, action executes. This adds maybe 90 seconds of latency to remediation, which is completely acceptable compared to a 40-minute self-inflicted outage. For low blast radius actions, restarting a single pod, scaling up a non-critical service, you can let the AI act autonomously. But draw that line clearly, document it in your runbooks, and never give any AI agent direct exec access to production namespaces. Dry run mode first, always. And there's one more requirement that's now showing up in compliance audits that most teams aren't ready for. Let me make this real. AI audit logs are not a nice-to-have anymore. I'm seeing this come up in SOC 2 audits and ISO 27001 reviews right now. When an automated system makes a change to your production environment, auditors want to know exactly what signal it acted on, what alternatives it considered, and why it chose the action it did. That's not something you can reconstruct after the fact from CloudTrail or Kubekel audit logs alone. Your AI agent needs to write a structured audit record at decision time, not just action. Rollback service X, but the full reasoning chain. Observed. P999 latency 200 milliseconds. Threshold, 2000 milliseconds. Recent change, deployment at 1431. Alternatives considered, scale up, rejected. Latency pattern not consistent with load spike. Config rollback, rejected. No config changes in window. Deployment rollback, selected. Highest correlation. Confidence, 84%. Blast radius, 4-5. Escalated to human. Every field, structured JSON, immutable append-only log. Store it alongside your incident records. This is the difference between a platform that survives a compliance audit and one that fails it. And now that we've covered what breaks when AI acts too autonomously, the next story is about a completely different kind of failure, one that happens slowly, quietly, inside the platform team itself. Here's the irony that I find genuinely painful to watch. Platform engineering teams exist to eliminate developer toil. They build self-service platforms so developers don't have to open tickets to provision databases or create namespaces. They automate the repetitive work. And then, 6 months into running a mature IDP, the platform team itself is drowning in toil. They're maintaining 37 backstage plugins, each with its own dependency tree. They're managing cross-plane compositions that break every time provider updates an API. They're keeping Terraform modules compatible across 4 different Kubernetes versions that different internal teams haven't upgraded from yet. They have a Helm chart graveyard. Nobody knows which charts are still in use. And they're the only team that doesn't have an SLO for their own services because they were so busy writing SLOs for everyone else that they forgot to write their own. This is second-order toil, the toil created by the tools you built to eliminate toil. And the cognitive load it creates is exactly why platform team burnout rates are quietly through the roof right now. But here's the thing. Mature platform teams have already figured this out. Let me show you exactly how they structured their way out of it. So how do the mature platform teams solve this? They do something that sounds almost too simple. They treat the IDP exactly like an externally facing API product. Semantic versioning, deprecation policies, migration guides, changelogs, and platform-level SLOs with an actual on-call rotation. Let me make this concrete. When a platform team ships a breakage to a backstage plugin or a cross-plane composition, they don't just push it and tell teams to update. They version it. IDP API versioned 1 to 2.22 is a minor change, backward compatible. 2.1 to 3.0 is a major version with a 6-month deprecation window, a migration guide, and automated migration tooling where possible. The platform team is on call for the IDP with a defined SLO. 99% availability during business hours. P1 incidents acknowledged within 15 minutes. This creates accountability. It changes how the team thinks about every decision. If I ship this change, I'm the one getting paged if it breaks. And it creates a forcing function for quality. The teams that have implemented this model have cut their reactive maintenance work. by over 60%, because they stopped letting technical debt accumulate silently. And this is exactly the mindset you need heading into your 90-day transition roadmap, which is what we're building in the next chapter. All right, let's get brutally honest. Last chapter, we talked about what breaks in production. Now let's talk about what's broken in your resume. Specifically, the gap between what you think makes you a platform engineer and what hiring managers are actually looking for in 2026. I've reviewed dozens of DevOps engineers who applied for platform engineer roles, and the pattern is painfully consistent. They're phenomenal at running systems. Zero experience designing systems that other engineers can self-serve from. Look at this matrix. You know CI/CD pipelines? Great. But can you design a self-service API that abstracts that pipeline so a product developer never has to touch a YAML file? You know containerization, but have you ever built an IDP portal catalog entry with a backstage software template? Monitoring? Everyone claims they own it. But have you ever measured developer experience with quantifiable metrics and reported it to a VP? This gap is not about seniority. I've seen 8-year veterans fail platform because they've never had to think about their infrastructure users as customers. That mindset shift, from operator to product owner, is the hardest thing to fake in an interview. In the next scene, I'll show you exactly which 3 gaps will kill your application before it even reaches a technical screen. Here are the 3 killers, the 3 things that disqualify most experienced DevOps engineers from platform engineer roles before the technical interview even starts. Number 1, you cannot design a self-service infrastructure API. Not consume one, design one. When an interviewer asks how would you let a developer PostgreSQL database without a Jira ticket, and you answer I'd write a Terraform module and give them the repo link, you just failed. That's not self-service. That's just shifting the YAML problem to a different person. Number 2, you've never written a Backstage plugin or software template. Backstage is the de facto IDP portal standard in 2026. If you can't even spin up Backstage locally and build a basic scaffolder template, you're signaling you've never actually built a developer platform. You've only built infrastructure. Number 3, and this one stings, you've never owned product metrics for your platform. You don't know your deployment frequency, you don't know your developer NPS, you don't know your onboarding time to first deployment. You've been measuring some metrics, not product metrics. These 3 gaps aren't impossible to close. But here's the uncomfortable truth. They take deliberate practice, not just more Terraform experience. The good news? I've got the exact 90-day plan to close all 3. Stay with me. Before you spiral into imposter syndrome, let me balance the picture. Because this is where DevOps engineers have a structural advantage that pure software engineers moving into platform roles will never have. Your deep Kubernetes experience. That's not just transferable, it's irreplaceable. A software engineer who's never debugged a crash loop back off at 3 a.m., never tuned resource limits to stop own kills from taking down production, they cannot own a Kubernetes-based IDP platform. Not safely. Your observability stack ownership. The fact that you've actually wired up Prometheus, configured Loki, and traced a latency issue through Jaeger means you understand what platform-level observability should look like. Most software engineers have only consumed dashboards. You've built them. And your security posture work, CS benchmarks, pod security policies, network policies, secrets management with Vault. This is foundational to a secure IDP, and it's brutally rare in candidates coming from application development backgrounds. So the framing is this. You are not starting from zero. You are adding a product layer on top of an operational foundation that your competition does not have. The 90-day plan I'm about to show you is specifically designed to add exactly that product layer, without wasting time on things you already know cold. What those 90 days look like specifically, that's the next section. Okay, concrete deliverables. No vague learn platform engineering bullet points. Let me tell you exactly what to build in the first 30 days, because this is the artifact that gets you past the resume screen. Day 1 through 7. Clone the Backstage repo, run it locally with Docker Compose, and get it talking to your gigization. I'm serious, just run it. Most people spend a week reading docs and never actually touch it. Don't be that person. Days 8 through 20. Build one golden path template for a real service type that exists at your company. Pick something you know well, a Node.js microservice, a PON fast API service, whatever. Build a Backstage software template that scaffolds the repo, wires up the CI pipeline, creates the Kubernetes namespace, and registers the component in the catalog. One template, end-to-end. Days 21 through 30. Wire that template to an existing Terraform module using Backstage scaffolder actions. When a developer's out the template form and hits create, Terraform runs and the infrastructure exists. Then write a developer journey doc, literally, step by step what the developer experienced, how long it took, what questions they had. That document plus the working template is your portfolio artifact. I have seen candidates with 10 years of DevOps experience get rejected, and candidates with 2 years get hired purely based on whether they're this kind of concrete deliverable to show. The interview question, "Can you walk me through something you built?" just became your strongest moment. But 30 days is just the foundation. Day 31 is where it gets interesting. Days 31 through 60. This is where you make the jump from "I built a demo" to "I understand platform product thinking." And that jump is exactly what separates platform engineers from DevOps engineers who are just playing with new tools. Your primary technical task: build a cross-plane composition, or if you prefer, a Terraform CDK construct that lets a developer provision a PostgreSQL database with a single YAML file. A single file. The developer writes something like "API version, platform my compom v alpha 1 kind database instance, spec, tier, dev engine, Postgres, SaaS small." That's it. No subnets. No security groups. No EAM policies. No regulation. All of that complexity is abstracted inside your composition. This is what infrastructure as a product actually means. Here's the critical part of this phase that most people skip. Interview 3 developers your company. Not a survey. Act 30-minute conversations. Ask them, what's the most painful thing about provisioning infrastructure today? What takes longer than it should? What do you avoid doing because it's too hard? Their answers are your product roadmap. Also in this phase, establish a baseline NPS score. Send a 3-question survey to developers who use your team's services. How likely are you to recommend our platform to another team? What's the one thing we should fix first? You will be shocked what you hear, and you will have data, actual product data, to talk about in interviews. But wait, the most impressive thing you can add to this portfolio? That comes final 30 days. Days 61 through 90. This is your finishing move, and it's the thing that makes your portfolio genuinely 2026 ready. Not just 2023 with a new coat of paint. Your AI integration spike. Pick one. Either build an incident summarization tool. When a PagerDuty alert fires, an LLM automatically pulls the last 50 log lines, the recent deployment history, and the relevant runbook, then posts a structured summary to Slack before anyone even pages the on-call engineer. Or build a deployment risk scorer. Before a PR merges, an LLM analyzes the diff, checks historical incident patterns for similar changes, and posts a risk score with specific concerns. Either of these takes about a week to wire up with LangChain or a simple OpenAI API call. They are not production-grade AI systems. They don't need to be. They demonstrate that you understand where AI adds value in a platform context, which is the only thing interviewers are actually testing. Then define your platform SLOs. Not system SLOs, platform SLOs. Golden Path template provisioning completes in under 3 minutes, 29% of the time. Developer self-service API returns a response in under 500 milliseconds. Finally, presently present your IDP as a product demo to your org. Record it. Post it on LinkedIn. Put the GitHub repo in your resume. This 3-part portfolio, backstage template, self-service API AI integration, is what gets platform engineer interviews in 2026. Not another AWS certification. Not another Terraform course. This. And in the next section, I'll tell you exactly which certifications actually matter versus which ones are just expensive resume decoration. Let me give you the 2026 platform engineering stack without the hype and without the omissions. These are the tools that appear in actual job descriptions, actual architecture reviews, and actual on-call rotations at companies running mature IDPs. Layer 1, the IDP portal. Backstage. Not port, not Cortex, not ops level, not yet. Backstage is the standard because it's open source, it's CNCF hosted, and the plugin ecosystem has reached critical mass. You need to know how to run it, extend it, and build Scouther templates. Layer 2, infrastructure abstraction. Crossplane. This is your replacement for give developers a Terraform module and a Confluence doc. Crossplane compositions let you define infrastructure APIs as Kubernetes CIDs. Developers apply a YAML, Crossplane reconciles the actual cloud resources. It's GitOps native, it's auditable, and it integrates with every Kubernetes native tool you already own. Layer 3, GitOps engine. Argo CD. Not Flux, but Argo CD has won the enterprise market on UI and multi-cluster support. No application sets. Know how to structure your app of apps pattern. Layer 4, networking. Cilium with eBPF. This has replaced kubeproxy in most serious Kubernetes deployments. Network policies at L7, built-in Hubble observability, Tetragon for runtime security. This is not optional anymore. Layer 5, observability. OpenTelemetry as the collection standard, full stop. Not proprietary agents. OTel collector pipelines, OTLP protocol, context propagation. Layer 6, KDA for event-driven autoscaling. Scale on queue depth, not just CPU. Critical for platform teams running shared workloads. Learn these 6. Everything else is secondary. But which certification should you actually spend money on? That debate. Right now, certifications. Let me save you several $1,000s and 6 months of misallocated study time with a brutally honest breakdown. CKA, Certified Kubernetes Administrator, is now table stakes. It's the minimum credibility signal. If you don't have it and you're applying for platform engineer roles, you will be filtered. Get it. But it will not differentiate you. CKS, Certified Kubernetes Security Specialist, this one actually moves the needle, specifically at security-conscious organizations, financial services, regulated industries. Platform teams at those companies are responsible for cluster security posture, and CKS proves you take it seriously. Time investment is significant, about 6 to 8 weeks of focused study, but the interview impact for the right companies is disproportionate. Now the new signal, the CNCF Platform Engineering Certification, also known as PCA. This is the one that didn't exist 2 years ago and is now appearing in platform engineer job postings as a preferred qualification. It covers IDP concepts, developer experience, platform topologies, and golden path design, exactly the conceptual layer that CKA does not touch. It's not cheap, but if you're targeting platform roles specifically, this is the cert that says I have thought about this as a discipline, not just as infrastructure. What about AWS, GCP, Azure certs? Honestly, useful if you're targeting cloud-specific platform teams, but they don't signal platform thinking. They signal cloud operations. Know the difference. The final certification worth mentioning? None, if you have the portfolio we just talked about. A working backstage IDP beats any certification in a technical interview. Every single time. And that's exactly the mindset we're taking into the final chapter. What do you actually do this week? That's where we're going next. All right, let's get into the stuff nobody puts in the official documentation. I've seen platforms spend 6 months building a beautiful Kubernetes abstraction layer, custom CRDs, operator pattern, and then discover that half their developers still don't understand what a pod is. That's anti-pattern number 1, abstracting Kubernetes before your org actually understands Kubernetes. You're building a ceiling over a floor that doesn't exist yet. And pattern number 2 is the portal first trap. I've personally watched a team burn 3 engineering quarters, a backstage developer portal, complete with custom plugins and a gorgeous UI, and on launch day they had 11 users. 11. Because nobody asked for the portal, the platform team just assumed the pain. Anti-pattern number 3 is the one that's going to get people fired in 2026, giving AI agents unrestricted production access. I don't care how smart your LLM is. If your Copilot agent can kubect delete in production without a human approval gate, you are one hallucination away from a P0 incident. Anti-pattern 4. Treating the IDP as an internal IT project instead of a product. No roadmap, no user research, no deprecation policy. Just a Confluence page that says use this. And 5. Never deprecating old golden paths. You end up with 6 ways to deploy a service, and nobody knows which one is current. The moment you stop killing old paths, your platform becomes a graveyard. But here's the thing. Every single one of these anti-patterns has a mirror image best practice. And that's exactly what we're looking at next. Now let's flip every one of those anti-patterns into a concrete best practice. First, start with 1 golden path for the highest paying workflow, not 5. Not a framework. 1. Find the workflow that causes the most developer complaints. Usually it's how do I get a new service to production, and build exactly that path end to end with guardrails. Everything else waits. Second, measure developer NPS quarterly. Not once, not never quarterly. Build a 5-question survey, put it in Slack, track the score over time. If your platform NPS is below 40, you have a product problem, not a technical problem. Third, and this one is underrated, write a platform team charter that explicitly defines what the platform does not own. I've seen platform teams collapse under scope creep because nobody wrote down we do not own application business logic, or we do not own data pipelines. Write it down. Fourth, treat every IDP feature as a product decision with a rollback plan. Before you ship a new golden path, define what this feature failed looks like and how you revert without breaking the 50 teams already using it. This is the discipline that separates platform teams from infrastructure teams. And fifth, and I cannot stress this enough, version and set your golden paths like software releases. Deprecation notices, migration guides, a sunset date. You're not killing old paths. You're not doing platform engineering. You're doing platform hoarding. Now, 3 things you can actually do this week. Let me show you exactly what those are. I know what happens after most technical lectures. You close the tab, you go back to your Jira board, and 3 weeks later you remember you watched something interesting, but can't recall what you were supposed to do differently. So let's prevent that right now with 3 actions you can physically complete this week, not this quarter, this week. Action 1, run the backstage cart locally and build 1 template. I mean literally open your terminal right now after this video. The command is npx at backstage create app. It takes under 10 minutes to have a running local instance. Then pick one thing your team deploys repeatedly, a node service, a Lambda, anything, and write one software template for it in YAML, just one. That single template will teach you more about the IDP model than any blog post. Action 2. Complete the skill gap audit against the matrix we covered in Chapter 5. Be honest. Rate yourself on Golden Path Design, Backstage Plugin Development, AI Workflow Guardrails, and Platform Product Management. The gaps you find are your learning roadmap for the next 90 days. Action 3. Join the CNCF Platform Engineering Slack. The invite link is free at platformengineering.org. And find one accountability partner, someone else who's doing this transition. Share your skill audit with them. The engineers who make this transition successfully almost never do it alone. But here's the deeper question you need to sit with before the final scene, and I promise this one will stick with you. Here's the prediction I'm going to my reputation on for 26. The AI infrastructure market is going to create enormous demand, but not for prompt engineers, not for people who know how to chain LLM calls together. The explosive demand will be for engineers who can build the platform that makes AI tools fully, reliably, and auditably available to everyone else in the organization. Think about what that actually means. Every company is going to have AI agents. Most of those agents will need infrastructure. They need sandboxed execution environments, secret injection, approval workflows, cost guardrails, audit logs. Someone has to build that. Someone has to own that golden path. That someone is the platform engineer. The engineers, who will be irreplaceable in 2026, are not the ones with the longest list of AI tools on their resume. They are the ones who can look at a chaotic AI adoption moment. Every team running their own models, their own pipelines, their own access patterns, and say, I can build the platform that makes this safe, scalable, and governable for everyone. That is the highest leverage role in the entire AI transformation, and it has platform engineer written all over it. You've watched all 6 chapters, you have the roadmap, you have the checklist, you have 3 actions for this week. The only question left is whether you decide to be the person who builds the platform, or the person who waits to be replaced by one. The choice is entirely yours. Go build something.